Chapter 8 Quadrilateral Exercise 8.2 Question number 4 ABCD is a trapezium in which AB parallel to DC, BD is a diagonal and E is the midpoint of AD, and a line is drawn E parallel to AB intersecting BC at F. Show that F is the midpoint of BC. So here AB parallel to DC, E is the midpoint. So AE equal to ED. Now the next point I cannot mark here because a line is drawn through E is parallel to AB intersecting BC at F. Otherwise I'll mark like this, a second line parallel. Okay, so that means this is parallel to this, and also DC is parallel to AB. That is why we are not writing like that. Show that F is the midpoint of BC. So what is given in the figure? That is AB parallel to DC is the midpoint. So AE equal to ED. Now EF parallel to AB. To prove F is the midpoint of BC, that means BF equal to FC. So proof we can. So the first step, AB parallel to DC, EF parallel to AB. What is implications? Means both are parallel to AB, that means EF is also parallel to DC. Right, so I can mark here 2 times because now we have proved all the 3 lines are parallel, right? AB parallel to DC, EF parallel to AB implies EF parallel to DC. So all the 3 lines are parallel. Now the first part of the question is over. Second part, in triangle ABD, you can see the figure that when the diagonal BD is joined, 2 triangles we are getting, which are they? ADB and also BDC, right? So ADB we are taking. In triangle ADB, what is given there? E is the midpoint of which side? AD. And EG parallel to AB. EG parallel to AB. The first side is AD. We have taken out the triangle, and AB is the second side. So by converse midpoint theorem, G bisects the third side. So G bisects BD. All this property or statement is by which we are writing converse midpoint theorem. This implies BG equal to GD. What is the meaning of BG equal to GD? G is the midpoint of BD. So now the triangle name we are changing. Which is the triangle name we are taking? BDC. In triangle BDC, G is the midpoint of BD, GF parallel to DC, then F bisects the third side of the triangle, that is BC, implies BF equal to FC. Again, what is the meaning of this one? F is the midpoint of BC. Hence proved. So what is the first step? We had given in the question AB parallel to DC and E is the midpoint of AD. EF parallel to AB is given. So the AB, EF, DC must be parallel. Then only we can use converse midpoint theorem here. So what we are doing, first step, AB equal to DC and EF parallel to, AB parallel to DC, EF parallel to AB. That means all the 3 lines are parallel. Now what is the next step? That means EG is parallel to this base AB and GF is parallel to DC also we got, because it's a part of EF. Now in triangle ADB, by converse midpoint theorem, what we can write? E is the midpoint of AD EG parallel to AB, that means G bisects BD, right? That means G is the midpoint of BD. Now we can see that triangle, next triangle we have to go for that one. That is which one? BDC. G is the midpoint of the first side BD, GF parallel to the second side DC, then F bisects the third side BC. That means F is the midpoint of BC, hence proved. Question number 5. In a parallelogram ABCD, E and F are midpoints of the sides AB and CD respectively. Show that the line segment AF and EC trisects the diagonal BD. Line segment AF and EC. Line segment AF and CE trisect the diagonal BD. So what is given in the question? ABCD is a parallelogram. So parallel side we can mark it. Opposite sides are parallel and equal. This is the second side, right? So two pair of opposite sides are equal and parallel we have marked. Now what is the next point? E and F are the midpoint. That means AE equal to B, because E is the midpoint. F is the midpoint means what we can say? DF equal to CF. Show that the line segment AF and EC trisects the diagonal BD. That means what? DP equal to PQ equal to BQ. That means this diagonal is divided into 3 equal parts. Okay, so what is given in the question? We will write first. That is ABCD is a parallelogram. AE is the midpoint means AE equal to BE. What about F? DF equal to CF. To show that means to prove DP equal to PQ equal to BQ. So let us see the proof now. Already the lines are joined in the diagram. Diagram is given, so we can go for the proof now. So first step is that ABCD is a parallelogram, means we can write that AB parallel to CD, right? And AB equal to CD. What is the reason? Opposite sides of the parallelogram. If AB parallel to CD, then the part of AB is AE. Then part of DC, we want to take it as a CF. So CF only I am taking AE parallel to CF. Next, AB equal to CD. Then half of AB equal to half of CD. Right? What is half of AB from this figure? Either I can write AE or we can write BA. Right? So we will write AE only. Next, half of CD means either we can go for DF or CF. But according to the question, we should need CF. So we are writing CF here. So now you check this statement. AE parallel to CF, AE equal to CF. That means one pair of opposite side is equal and a parallel. That means AECF is a parallelogram. So here I'll write, therefore, one pair of opposite sides is equal and parallel. Therefore, AECF is a parallelogram. What is the name? AECF is a parallelogram. First we have written that AE parallel to CF, AE equal to CF. Now we have proved that, based on that we have proved that AE CF is a parallelogram. So now which is the remaining side that we are not considered for this parallelogram? That is AF parallel to CE and AF equal to CE. Means other pair. Therefore we can write, because by the result of AECF is a parallelogram, we can write AF parallel to CE and AF equal to C. That means the other opposite side we have written, right? Now we know that if AF parallel to CE, take that one AF. So can we write that AP parallel to EQ because both are parts? Yes. Similarly, FP parallel to CQ. Again, FP is a parallel to AF and CQ is a parallel of CE. That is why by AF parallel to CE, what we can write? AP parallel to EQ and also FP parallel to CQ, that we required for proving. This step is not required for you. While writing the proof it will come, but I am explaining here only. If AF parallel to CE, then it's a parts of the line segment is also parallel. So AP parallel to EQ and FP parallel to CQ also there. This is the first part. What is the first part? AECF is a parallelogram. If this step is excluded or this proof part, this first step is not written, then the second and third step is not valid. Clear? So I will continue now. What is the remaining steps we got? Now what is the next step? Means from B we have to choose the triangle. BAP is the triangle first. So converse midpoint theorem only here also we have to use. I'll write converse midpoint theorem. Right? In triangle BAP, what is the midpoint? E is the midpoint. E is the midpoint of AB. EQ parallel to AP. We have proved in 1. So I can write here proved in 1. So okay, this is also result of 1 only. I'll make it here 1 also. So here otherwise 2. Okay, 2 I'll write here also 2. Okay, there is no confusion. Okay, proved in 2. Now EQ parallel to AP I have written. Now what is the next step? Q is the ending point. Q bisects the third side. That means BP implies BQ equal to QP, equation number 3. Right? Similarly, which is the next triangle I have to consider with a D. Opposite diagonal only we have to take a BD trisection we have to prove. So B I have taken. Now D. DQC. In triangle DQC, which is the midpoint there? F. F is the midpoint of CD. FP parallel to CQ. So next, what is the next point? P bisects the third side DQ, implies DP equal to PQ, equation number 4. Using 3 and 4, what I can write? Using 3 and 4, we can write that BQ equal to PQ equal to DP. See that one diagonal BD, BQ, PQ and DP, all 3 are equal. That means, what is the meaning of this one? The diagonal BD is divided into 3 equal parts. Hence proved. We have to prove that the diagonal BD is divided into 3 equal parts. The first step is that we should prove AECF is a parallelogram. For that, what we have to do? AB parallel to CD, AB equal to CD. If AB parallel to CD, then AE parallel to CF. Naturally, we can write. Now, half of AB equal to half of CD means AE and CF are also equal. So, one pair of opposite side is equal and parallel. So, we got AECF is a parallelogram. Children will forget to write this step. That is wrong. Once you have proved a parallelogram, then only this parallel property we can apply. That means one pair we have proved, the other pair parallel. By the result of this only we are getting. It is not given in the question. So AP parallel to EQ, FP parallel to CQ we can write, because once we have proved the parallelogram of this, that is AECF, AF is also also parallel to CE. So we can write AP parallel to EQ, FP parallel to CQ. Now what is the next step? That is the converse midpoint theorem. So the first triangle we are taking BAP. In this, E is the midpoint of AB, EQ parallel to AP. Now what is the next step? Q bisects BP. Therefore we got BQ equal to QP. Next part. So F is the midpoint of CD. Now FP parallel to CQ. So P bisects DQ. So what we got here? DP equal to PQ. Now 3 and 4 we can say that all the three parts are equal. So what is the conclusion? BD divided into 3 equal parts, hence proved. Now listen carefully. Without proving AECF is a parallelogram, if you are applying converse midpoint theorem, then the proof is completely wrong. No mark will get. So first step should not avoid. What is the first step? AECF is a parallelogram. What is the second step? Converse midpoint theorem in BAP. What is the third step? Converse midpoint theorem in DQC. Then we can prove that the diagonal BD is divided into 3 equal parts. With this, today's class I am winding up. Thank you.